right, this is 9.6, solving equations. An equation is a statement that shows that two expressions are equal to each other. So here's examples. So they're saying that x plus 1 is equal to 9. So this side equals 9 and this side equals 9. 20 is equal to 5k. Well, 20 is equal to 5 times whatever k is. Same thing with this last one. 6 times r minus 1 is 17, right? They're going to be the same on both sides. So that's what these are saying. So the first thing that we're going to do in this lesson is to determine if a solution or an answer, a number is an answer of an equation. So this one they said, is 7 an answer of one or both of these equations? So if that's the case, the thing that we're missing is x and y. And they're saying, is 7 the answer that we need to be able to plug in both of those to make sure that the left side and the right side of the equal sign come out to be the same? So let's see. The left side is 12 and the right side is 7 plus 5. The right side adds to be 12 and the left side is 12. So yes, this one worked out, right? This one is 2 times 7 plus 1 equals 16. Well, 2 times 7 is 14. 14 plus 1 equals 16. 14 plus 1 is 15. 15 does not equal 16, so no. So you're not moving things from side to side. You're just trying to see if the left side equals the right side and say yes or no. Okay? All right, so when we solve, we actually are trying to put letters on one side and numbers on the other side of an equation or of an equal sign, okay? And so I want to move this 4 away from the k and move it to the other side. So I do the opposite of what I see. So if I see a negative 4 or a minus 4, I do the opposite, which is to add. Right? If I have negative 4 and I add 4, I get 0 over here. So that's what I wanted. I didn't want that over there anymore. What I did to one side of the equal sign, I have to do to the other side to keep it balanced. And so the left side becomes k and the right side becomes 6 plus 4. Well, 6 plus 4 becomes 10. And so k equals 10. Okay. We're going to solve this one. Again, we want letters on one side, numbers on the other side. It's okay that the letters are on the right. And it's okay that the letters sometimes are on the left, as long as they are separated. Letters on one side, numbers on the other side. So I'm going to move this 8. And I have a plus 8, so I have to do the opposite, which is a minus 8. Because that gives me 0, and all I have left on this right side is z. What I did to one side, I have to do to the other side. And so now I have 2 minus 8. Remember that I want an addition problem, so I change the sign. So I have 2 plus a negative 8. Signs are different. I subtract and I take the sign of the bigger number, and so I find z equals negative 6. All right, I need letters on one side, numbers on the other side, and this right here is what's holding me up, right? The 9 and the p are touching. When things are touching, what is happening between them? It's multiplication. How do you undo multiplication? What's the opposite? You divide by whatever it is that you want to go away. And in this case, we want the 9 to go away because we want p all by itself. What I did to one side, I need to do the other side. And so I divide the other side also by 9. And in this case, 63 divided by 9 gives me 7. They're both positives, right? Signs are the same, so the answer is positive, so I get a positive 7. Same thing here. The negative 4 and the r are touching. I want to divide by whatever it is I want to go away from my letter, and I want to get negative 4 to go away. So I end up with r on this side, and 24 divided by a negative 4, signs are different, the answer is negative, and 4 goes into 24 12 times. Oh, sorry, 6 times. Got carried away there. Trying to look at the next example. 6, because 24 came about because 4 times 6. So this is our final answer. All right, I need m all by itself. I need to get the negative 11 away from it. These two are multiplied together. To get them apart, I do the opposite, which is to divide by the number that I want to go away. I do the same thing on the other side to keep this a balanced equation. And so I have m equals, well, signs are the same, so the answer is positive. 11 goes into 55 5 times, so m equals 5. All right, so this one's a little tougher to identify, but it scares people because they look at it and they think it's a fraction, which it is. But remember that all fractions are a division problem, are division problems. And so what's the opposite of divide? To multiply. And we multiply by whatever it is that we want to go away. And we want the 2 to go away from our x. So when I multiply this side by 2, the numerator and denominator cancel, leaving just x. And so I do the same thing to the other side. I multiply by 2. I don't need it to be 2 over 1 because 9 is a whole number. So 9 times 2 is 18. 9 and 2 are both positive numbers. Signs are the same. The answer is always positive. So this is my final answer.